To understand asynchronous JavaScript, we first have to understand the JavaScript engine, like V8, which powers Chrome. JavaScript is famously single-threaded, meaning it can only do one thing at a time. Picture your entire codebase as a single-file grocery line. If one operation takes a long time, the whole line stops. But JS has a superpower. It doesn't wait in line. It can delegate work. And that delegation is the key to asynchronous coding. Let's see that in action. When your main script runs, everything is on the call stack. If a function is simple, like hello world, it is processed instantly. But if a function has to fetch data from a server or wait for a timer, it has to move. If it doesn't, the entire browser freezes. JavaScript handles this by delegating that heavy lifting to the web browser's APIs, like the network stack, freeing up its own stack to keep the user interface smooth. It's like sending a courier to get groceries while you stay home and keep cleaning. But how does the engine know when that delegated work is done? Meet the promise. A promise is exactly what it sounds like. It is an object representing an operation that will eventually finish. A promise is always in one of three states: pending, still fetching data; fulfilled, success, data is here; or rejected, failure. We handle these results with a beautifully simple chain: .then for success data and .catch for errors. A promise is JS's guaranteed contract for the future. Chaining .then. Blocks is powerful, but it can get messy. To make our code read like synchronous, simple instructions, ES 2017 introduced async/await. By adding the async keyword to a function, we declare it is special. Inside, we use await to pause the function execution without blocking the single thread. It's syntactic sugar that makes complex network fetches look as simple as const result equals await get data. This blueprint is how modern developers maintain clean, efficient, and readable concurrent code. The engine that powers this whole process is the event loop. This loop constantly checks if the main call stack is empty. When it is, the delegated tasks are finally pushed back onto the stack to finish. Our key advanced takeaways. First, JS manages single-threaded limitations by delegating I/O work. Second, promises act as contracts for future data. And third, async/await is the modern standard for writing asynchronous logic that is elegant and easy to read. You've now unlocked true concurrency in JavaScript. Happy engineering!